Okay, linear sequences are nothing too complicated in this lesson, just straightforward sequences. Right, so this is the first one you've got to do, fill in the boxes. And not the hardest task. So 2, 4, 6, 8, fill in the next ones, have got to be happen. Pause video. Clearly it's nothing complicated, it's just 2, 4, 6, 8, 10, 12. This one here goes up by 5, that one here goes down by 3, just looking for the differences. Now all these sequences, they go up in the same amount each time or go down in the same amount each time. So these are linear sequences. Okay. And the only difficult one is really this one here, which is the last one. But what you really got to think about is if I've got 2 spaces and the difference is 24, then you've got to think about how much would each space be. So you actually have to do 24 divided by 3. Yeah. Right. Okay. So I've directed to this website here, but mine's already got them listed up, which is in Enrich, which is nice. So let's say we've got a sequence here. Now this sort of looks like a times table, but it's either been moved up or it's been moved down. Okay, so have a look at this. Now if you're looking at your differences, the difference here is actually 6, and I could do 11 take away 17, which is 6, or I could do 17 take away 23, which is 6, but it's not a 6 times table, it's actually more than that. Yeah. So ask yourself, what do I have to add to 6 to get to 11, which would be 5. So it's a 6 times table shifted up by 5. Okay, checked. Well done, that's right. Let's do it again. See what the difference is. Oh, it actually is 6 again, because 16 take away 10 is 6. But of course, you could do 28 take away 22, which is 6. And it's got to be the same way along. 6 plus what is 10? 6, 7, 8, 9, 10. So it's 4. So plus 4. Check. Well done. Yeah. And this is essentially you building up of your nth term. So ask yourself again, what times table is this? So 5, 6, 7, 8. So this is your 8 times table. Right. And then what do I have to add to 8 to get to 15? So 8, 9, 10, 11, 12, 13, 14, 15, which is 7. Okay, but you wouldn't say 8 times table shifted up by 7. What you would call it, you'd call that 8n plus 7. So my nth term here is 8n plus 7. So this one here, I don't know why it keeps using me 8, but my times table is 8. So if I was going to write this down, I'd write it down as 8n plus 2. And that's how you do your nth term. Yeah, good. So work these out, work way through your nth term. If you need practice, load up to that Enrich website. But I'll do the first one just for you. Okay, so the times table from there to there is going to be 7, so it's going to be 7n. Ask yourself, how do I get from 7 to 10? So 7, 8, 9, 10, which is 3. Okay. Work your way through all of them. Please be careful on 5 and 6 on both sections. Okay, they're there to confuse you. And pause the video, do the work. Okay, right, and so before I actually talk through the answers, let's talk about 5. Now, when you look at your difference, you might reckon that your difference is 5. That's not true. Your difference is actually negative 5 because it's going down. So if I was going to write that, I'd have to write it as minus 5n. And the same rules apply. You ask yourself, what do I add to minus 5 to get to 50? Now, people get confused because that is a negative number, but it's got to be plus 55. Yeah, because you have to get to 0, which is 5, and plus the original 50. Yeah. So the same with number 6. If you look at it, that's going down by 9, so it's minus 9n. And then you have to add 99, because 9 minus 9 plus 99 is 19. So here's your answers. Let's hope that they are all correct. Might work. Let's move on. Okay, now we never actually spoke to our NEs, and it's really ridiculous, but a lot of kids forget what N is, and they go through loads of like things about like number or N or don't, but it actually stands for your position. Yeah, so this is your position of your term, and I'm sorry to make it's going to make you feel really sarcastic when I say this, but for my first like position, N is going to be 1. Okay, for my second position, N is going to be 2. My third position, N is going to be 3. So my 50th position, I'm actually going to call my 50th term, yeah, N is going to be 50. My 70th term, N is going to be 70. So to work these out, it's 5n plus 4. So I have to do, for the first time, it's just 5 times 1 plus 4, okay, which is 9. My second one is going to be 5 times 2 plus 4. Okay, 14, and 5 times 3 plus 4. Okay, so this one here, for my first term, N is 1. So I have to do 2 times 1 plus 4, okay, which is 6. I have to do 2 times 2 plus 4, and then 2 times 3 plus 4, and 2 times 4 plus 4. Yeah. And I've noticed that these do actually go up in 2. and that is actually my number here, which is 2. Okay, which is nice to work for linear sequences. So this one here, if I want the first 4 terms, I'm going to have to do, okay, going to have to do 1, 2, 3, 4. My first one I'm going to do 1 times 3, which is 3, plus 2 is 5. Then I have to do 2 times 3, which is 6, plus 2 is 8. Then 3 times 3, which is 9, plus 2, which is 11. And then 3 times 4, which is 12, plus 2, which is 14. Okay. And that's how you work out your sequences when you're listing them. Okay. Now, these are a little bit confusing when they're laid out. Essentially, these are the easier sequences, they're your medium sequences, they're your hardest sequences. Okay. If you want it to make it easy for yourself, just do just the first 5 terms. If you want to make it a little bit better, do the first 5 terms and the 10th, the 20th, and the 30th. If you're really good, do the first 5 terms, the 10th, the 20th, the 30th, and the 58th, the 35th.
And the 12th.
Just so you've got a variety of questions to do. Pause the video. Now, when I did this, I did it as a Excel. So here's all your answers. You've got your sequences here on your left and the position at the top. Mark your work, hopefully there's no mistakes. Right. So we need to ask yourself, in the sequence of 5n, is 22 in this sequence? Now, this is a fairly nice and obvious one to say because you know the sequence of 5n, you know that's your 5 times table. So you know 22 is not going to be in the sequence because it's either going to end in 5 or it's going to end in a 0, which 22 clearly doesn't. And then you'd have to write that down. The other thing you can do, you can write the sequence. So 5, 10, 15, 20, 25. Yeah, and then you can say, well, hang on a minute, I've listed it and 22 is not in the sequence. If you're doing it this way, it's important that you say it hits 20 and it hits 25 and it does not hit 22. So you've got to do the one above it and the one below it. But the way what I want to push you towards is solving it really. We can create an equation. So if I make 5n equals 22, if I solve this and then happens to be a whole number, then I know that 22 is in the sequence. So it's an easy one to solve. I just divide both sides by 5. So I've got n equals 4.4. Now, because 4.4 is a decimal, I know that can't be in the sequence. Okay? So you'd have to say, no, this is not in the sequence because n is a decimal number. Right. 7n minus 30 is 60 in a sequence. So again, I could list out all the possibilities. Okay? I can make an equation. So I could do 7n minus 30 is 60, and I solve it. So I plus 3 from both sides. Makes 7n equals 63. And then I divide it by 7 divided by 7. Okay. 63 divided by 7 is 9. So it actually tells me it's the 9th term. So now I can say 7n minus 3 is in this sequence. Yeah. Good, perfect. Right. So you've got all of these numbers here. I want you to work out which ones have 362 in a sequence, which ones have 12 in a sequence, which ones have 49 in a sequence, and which ones have 100 in a sequence. I want you to solve it with whichever way you want. Go pause the video if you want to. Okay. All of these have 362. And a red herring there just as well, just in case people can see that. And all of these have 12. These ones here have 49. And ones are 400. The only thing you might want to talk about is these ones to the right. Yeah. Now these are actually going down. Yeah. So technically you could argue because they're going down, yeah, they'll never hit 100 or hit any of the positive numbers. But there's nothing saying that you can't have a negative position. You know, like it does get confusing if you're talking like in the past or like going backwards, but essentially we can have negative positions. Okay.